Okay, so 7G.3, we'll finish with this. So if you've got your notes book open, this will be a pretty straightforward example. Just introducing you to some notation, okay? I told you about this tilde before, which means is distributed. B specifically means it's a binomial distribution. N is the number of trials, P is the probability of success. So we'll get straight into our example. The probability of a match being defective is 0.03. There are 50 matches in a box. Okay, so if X is the distribution of defective matches, well, there are 50 matches in a box and the probability of a match being defective is 0.03. We can say it's binomially distributed with 50 trials and the probability of a match being defective 0.03. Part A, find the mean, standard deviation and variance of defective matches. Okay, so let's look at those 3 dot points. The mean is just equal to N times P. All right, so the mean is 50 times 0.03. We evaluate that, we get 1.5. So on average, we have 1.5 defective matches per box. The variance is N times P times Q, which is 50 times 0.03, and Q is just the inverse probability of P, 1 take away P. So in this circumstance, 0.97.
Yeah.
1.455. And then the standard deviation is always the square root of the variance, so we can just square root that 1.46, or leave it like that. So that's, that's all part A, isn't it? Find the mean, variance, and standard deviation. All right, part B, okay? Part B. This is where we're going to use what we just did. I will evaluate that standard deviation quickly. Square root of the answer and convert to decimal. I've got 1.206, 1.21. Okay, find the probability of the mean, take the standard deviation, being less than the variable x, being less than the mean plus the standard deviation. Okay. Firstly, let's evaluate that. What is the mean plus the standard deviation? Okay, so if I have 1.5 plus 1.21, the mean plus the standard deviation is going to be 1.71. And the mean take the standard deviation, if I have 1.5, take away 1.21, I'll be left with 0.29. Okay. What is this asking us? Calculate the probability that between 0.29 and 1.71 matches, sorry, that should be 2.71, not 1.71. So sorry, where have I got that number from? 1.5 plus 1.21 gives me 2.71. All right, back on what we're doing. Calculate the probability that between 0.29 and 2.71 matches are defective. So let's consider how many matches we could have defective. We could have 0, we could have 1, we could have 2, or we could have 3. We could keep going, but it says less than, 0.29 is less than, so 0.29 is in here somewhere, and 2.71 is in here somewhere. And we are talking about discrete events. A match is either defective or it's not. So we're talking about this specific outcome, that we have 1 defective match or 2 defective matches. All right, what it means, 1 to 2 out of how many matches are there? 50, and the probability of it being defective, 0.03. So do that quickly. BCD. 1 to 2 out of 50, 0.03. And we've got 0.5927, 0.593. Okay, so we've found the mean, we've found the standard deviation, we just placed it into this formula, and we've figured out what is that asking specifically, what events is that asking. So 0.29 occurs here between 0 and 1, and the closest discrete, not the closest, but the discrete value that includes that boundary is 1. Okay, so that's why we've jumped up to 1. If we went to 0, that would be even lower. So we're not definitely not including 0, and we're definitely not including 3. Okay, very last part. Find the mean, standard deviation, and variance of non-defective matches. Okay, so that's part B. Part C. For a non-defective match, well, if the probability of it being defective is 0.03, then the probability of it being non-defective is 0.97. All right, so the mean of non-defective matches is 48.5. And interestingly, the standard deviation and the variance are going to be the same because they have the same P and Q are just swapping. So the variance and standard deviation remain the same. I'll just write that, remain the same. Okay, so that's 7G.3. It just takes it a little bit further, gets you to perform those standard deviation calculations and then make some questions like this. All right, so let's